Hello everyone, welcome to today's lecture. So we have started with chapter 5. We have finished 3 lectures. You studied about anomalous behavior of water, latent heat and some terminologies like dew point, saturated with water vapor, unsaturated with water vapor and the definitions of unit of heat. Okay, now we may move on to the next topic, that is specific heat capacity. It is a value which is standardized to a particular material. Okay, for example, copper has a particular value of specific heat capacity. I will tell you in normal words what is specific heat capacity. If you heat oil in a vessel and if you heat water in a vessel, okay, consider you are heating water and the oil for about 5 minutes. Okay, and if you are told to put your finger into either water or oil, you will always prefer water. Why? Because we feel that the temperature of water might be less compared to that of oil. Okay, actually it is the specific heat capacity. That means the heat content which is absorbed. We had studied in the first lecture that the heat of an object and temperature of an object, these are two different things. Okay, these are two different quantities in case of physics. So the heat absorbed by oil will be more than heat absorbed by water. Okay, the heat absorbed by oil will be more than heat absorbed by water. So we might feel it safe to put our finger in water instead of that of in oil, isn't it? Okay, so that value of absorption of heat, that is called as specific heat capacity. Okay, to explain this, in our textbook they have given an experiment. We will see what the experiment is. You have to take 3 spheres of iron, copper and lead. You have to take 3 spheres of iron, copper and lead. You have to put it into water and boil it for a particular period of time, equal amounts of time. Consider about 5 minutes. You have to boil it for 5 minutes. After boiling it for 5 minutes, you have to take those spheres and put it onto a wax layer. Okay, a layer of wax. It is seen that the wax will melt. Of course, the wax will melt because the hot objects are being put on them. It is seen that the iron sphere will go to the deepest level, then the copper and lead will go to the minimum level. Why? Because the sphere which absorbs more heat from water will give more heat to wax. Okay, the sphere which will absorb more heat will give more heat to wax. So who absorbed more heat? Iron absorbed more heat. So iron will give more heat to wax. That is why it is going to the deepest layer. Okay, now that means, what does this experiment mean? This experiment means that for equal rise in temperature, the 3 spheres absorb different amounts of heat. Okay, for equal rise in temperature, okay, for equal rise in temperature, for how many minutes we had heated it? Okay, for 5 minutes. Okay, the time limit was the same and the rise in temperature was also the same. The initial temperature was the same, the final temperature was the same. So for equal rise in temperature, the 3 spheres absorb different amounts of heat. That heat absorbed is called as the heating capacity. Okay, the specific heat capacity. Now how will you define specific heat capacity? The amount of heat energy required to raise the temperature of a unit mass of an object. Unit mass means it could be 1 kilogram or 1 gram. Unit mass of an object by 1 degree Celsius is called specific heat of that object. Consider there is a sphere, there is copper sphere. Okay, the heat energy, the amount of heat energy required to raise the temperature of that 1 kilogram of sphere by 1 degree Celsius is called specific heat of that object. So SI unit is joule per kilogram degree Celsius. SI unit of specific heat capacity is joule per kilogram degree Celsius, and CGS unit is calories per gram degree Celsius. Now there is an equation in our textbook to find out the heat energy absorbed or heat energy released. What is the equation? The equation is Q is equal to M into C into delta T. Equation is Q is equal to M into C into delta T, where Q stand for heat absorbed or heat released, M stand for mass of the object, C stand for specific heat capacity of that object, and delta T stands for change in temperature, that means final temperature minus initial temperature. Okay, or higher temperature minus lower temperature. Okay, now what is the equation to find out heat absorbed or heat released? It is Q is equal to M into C into delta T, where Q stand for heat released or heat absorbed, M stand for mass, C stand for specific heat capacity, and delta T stand for change in temperature, that is higher temperature minus lower temperature. Okay, now this is the experiment. Now we'll come to the textbook on page number 68. The experiment is very important. Okay, the question is very frequently asked. It was asked in the boards last year also. Okay, so the question is there in the exercise. You may mark this question. You have to write the experiment and to write what is meant by specific heat capacity. There is a table given in the textbook on page number 68. In that they have given the specific heat capacity of different substances. You may mark the specific heat capacity of copper and water. Copper and water, they are asked. Okay, copper, water and iron also you may mark copper, water and iron. What is the specific heat capacity of water? It is 1 calorie per gram degree Celsius. 1 calorie per gram degree Celsius. What is the specific heat capacity of iron? It is 0.110 calories per gram degree Celsius. What is the specific heat capacity of copper? It is 0.095 calories per gram degree Celsius. While doing the numericals, this value of 0.095 is taken as 0.1 also. Okay, now we may move on to the next topic, that is principle of heat exchange. Even this is a very simple question, very important question. Principle of heat exchange. For this you have to take a box which is insulated, which is double walled, insulated, and there are two objects kept in it, one hot object and one cold object. They are kept in contact with each other. Okay, they are kept in contact with each other. What will happen? The temperature will flow from hot object to cold object, isn't it? Isn't it? Okay, so the temperature will flow from, the heat energy will flow from hot object to cold object. Till what level? Till what level? Till the temperature will be the same. Till the heat energy possessed by both will be the same. So, heat energy lost by the hot object is equal to heat energy gained by the cold object. That is principle of heat exchange. So, what is principle of heat exchange? Heat energy lost by the hot object is equal to heat energy gained by the cold object. Okay, so I repeat, there is a box which is insulated in which they have put two objects, one is hot and one is cold. What will happen? The heat energy will flow from hot object to cold object. Till when? Till the temperature of both the objects are the same. Okay, it won't happen that this will become cold and this will become hot. Both of them will become hot. Okay, the temperature of this will decrease and the temperature of this will increase. Okay, so heat energy lost by the hot object is equal to heat energy gained by the cold object. This is principle of heat exchange. If you are having a question on principle of heat exchange, you may write on page number 69, you may mark, if heat is exchanged between a hot and cold object, the temperature of the cold object goes on increasing due to gain of energy and the temperature of hot object goes on decreasing due to loss of energy. The change in temperature continues till the temperature of both the objects attain the same value. Okay, you may mark till there. Then you have to write what has been given in bold letters. That means this statement that heat energy lost by the hot object is equal to heat energy gained by the cold object. This is called principle of heat exchange. You may mark, I'll tell you again. If heat energy is exchanged between a hot and cold object, the first sentence itself, if heat is exchanged between a hot and cold object, the temperature of the cold object goes on increasing due to gain of energy and the temperature of hot object goes on decreasing due to loss of energy. The change in temperature continues till the temperature of both the objects attain the same value. You may mark till there. Marked? Now, the statement which is given below, the bold lettered statement, heat energy lost by the hot object is equal to heat energy gained by the cold object. This is called principle of heat exchange. Okay, now you may mark this in your textbook. Now the next is measurement of specific heat capacity. How the specific heat capacity of a material can be calculated. It is calculated, it is measured with the help of an instrument, a device which is called as calorimeter. It is the tool to measure the specific heat of a material. Okay, in your 8th standard you had studied about the structure of calorimeter. Now here I have given the structure of calorimeter. It is a double layered box. Okay, there is air cavity in between the two layers. It is having a cover and it is having two holes. Okay, through one hole you have to insert thermometer. Through the other hole you have to insert the stirrer. Stirrer means to stir, to mix the water inside. Okay. Now there is a vessel inside. This is the vessel. That vessel is made up of copper. Okay, the vessel is made up of copper. Now the object of which you have to find out the specific heat capacity, that you have to heat it and put it into this liquid. Okay, there is a liquid which is taken inside the vessel. Okay, there is a vessel inside the vessel a liquid is taken. Understood? Now in that liquid you have to put that hot object. What will happen? The hot object will lose temperature and the water, the liquid inside, will gain temperature. Along with the liquid, the vessel, that is calorimeter, that is the copper vessel, that will also become hot, isn't it? When you are pouring water, hot water into a vessel, the vessel also becomes hot. Similarly, when you are putting a hot object into the liquid also will become hot. The vessel in which the liquid is present, that also will become hot. Okay, they will exchange temperature. By principle of heat exchange, the heat lost by the hot object is equal to heat gained by the cold object. Okay, that means what will happen? Let the heat lost by the hot object, it is taken as Q. Okay, in the other clip I showed that what is Q? Q is heat absorbed or heat released, that is heat gained or heat lost, which is equal to m into c into delta T, where m stand for mass, c stand for specific heat capacity, and delta T stand for change in temperature, that is higher temperature minus lower temperature. Okay, now here it is taken as Q. What is Q? It is the heat lost by the hot object. It will be m into c into delta T. Okay, now the next, heat gained by the water or the liquid inside. Whatever liquid is there inside, it will gain water. It is taken as Q1. How will you find out that? It is m into c into delta T, where m is mass of the liquid, c is specific heat capacity of the liquid, and delta T is the change in temperature of that liquid, isn't it? Here, what is m? It is mass of the object, c of the object, delta T of the object. Okay, this is mass of the water or the liquid, c of the water or the liquid, and delta T of water or the liquid, whatever liquid you are taking. Now the third one is heat gained by the calorimeter. That means the copper vessel, that will also become hot. The heat gained by the calorimeter is taken as Q2, which is equal to m into c into delta T, where m is mass of the calorimeter, C is specific heat capacity of the calorimeter, and delta T is the change in temperature of the calorimeter. Okay, now heat lost by the hot object is equal to heat gained by the liquid plus heat gained by the calorimeter. Okay, this is the equation to find out the specific heat of an object, of a substance. So Q is equal to Q1 plus Q2, where Q is the heat lost by the whole hot object, Q1 is the heat gained by the water or the liquid, and Q2 is the heat gained by the calorimeter. So there are two equations of principle of heat exchange. The first one is heat lost by the cold object is equal to heat gained by the hot object. It is that equation because in that case there were only two objects, one hot object and one cold object. Okay, here there are three objects. One is the vessel, second is the liquid, and third is the object, okay, which you are putting into that liquid. So the equation becomes Q is equal to Q1 plus Q2, where Q stand for heat lost by the hot object, Q1 stand for heat gained by the liquid or the water, and Q2 stand for heat gained by the calorimeter, that is the copper vessel in which you are taking the liquid. Okay, now this is the basic thing for the numericals. Now we may move on to the numericals. So the first solved example we will see how much heat energy is necessary to raise the temperature of 5 kg of water from 20 degrees Celsius to 100 degrees Celsius. So there is water. How much water? It is 5 kg, and you have to increase the temperature from 20 degrees Celsius to 100 degrees Celsius. So the mass is given as 5 kg. Specific heat, we know the specific heat. You have to learn the specific heat capacity of water. It is 1 kilocalories per gram degree Celsius. Delta T, you have to increase the temperature from 20 to 100. Okay, so the change in temperature is higher temperature minus lower temperature, that is 100 minus 20, that will be 80 degree Celsius. Now the energy necessary, you have to find out what energy is needed. Heat energy is needed. How will you calculate the heat energy absorbed or heat energy released? With the equation Q is equal to m into C into delta T, where m stand for mass, C stand for specific heat capacity, and delta T is change in temperature, that is higher temperature minus lower temperature. Okay, so it becomes 5 into 1 into 80, that is 400 kilocalories. This is the simplest sum which is there in this chapter, and it is very frequently asked. You may practice this, okay, and you may mark this as important. Now the homework for today, it is define specific heat capacity and state the principle of heat exchange, and you have to write this solved example in your notebook. So we have finished with the chapter. Now we may practice the numericals. The numericals are one of the most important parts of this chapter, and the questions are asked. Okay, so first finish till here, finish the theory part of the chapter. Okay, thank you.